Want to know a surprising fact about earthquakes? There are lots of them. In fact, every day scientists detect about 55 at locations all around the world. But there are many more earthquakes that go undetected, which is estimated to be as many as 500,000 a year. When these earth-shaking events are powerful and occur in areas where there are many buildings and homes, they can do a lot of damage to structures and injure people. But even earthquakes that occur in remote areas can produce changes to our planet, especially to its crust or outermost layer. You can see the impact of an earthquake in this image, showing Earth before, during, and after the earthquake. Earthquakes are caused by the movement of the huge slabs of rock that make up Earth's crust. They are called plates. Earth's crust is composed of 7 major plates and many minor ones. These plates are always in motion, but sometimes they get wedged together along their edges. When this happens, the rest of the plate keeps moving, causing a large amount of energy to build up in the area where the plates are stuck. Eventually, the plates break free, and all that stored up energy is suddenly released. This vibrating energy moves outward, like the ripples on the surface of a pool of water when a pebble is tossed in. These vibrations are called seismic waves. They can be incredibly powerful, causing the ground to shake in all directions as they travel through Earth's layers. There are different kinds of seismic waves, depending on the type of vibration they cause as they travel through Earth. The action of this spring will help you understand how seismic waves are classified. When the end of the spring is moved back and forth, the vibrations move left and right along the spring. This is called a longitudinal wave. Now look what happens when we move the end of the spring up and down. The vibrations go up and down as they travel along the spring. This is known as a transverse wave. If we drew a picture of a transverse wave, it would look like the spring in motion. If we stop the motion, we can study the wave and measure it. The highest point on the wave is called the crest. The lowest point is known as the trough. By measuring the distance from crest to crest, or trough to trough, we can determine what's called the wavelength. Wavelength can also be determined by measuring from any point on one wave to the same point on the next. Another measurement we can take is the wave's amplitude or strength. This measurement is the distance from the center point of the wave to either the top of its crest or the bottom of its trough. Another measurement you'll often hear about in connection with earthquakes is magnitude. This is the strength of the earthquake in terms of the amount of energy that has been released. Scientists determine an earthquake's magnitude by taking a number of measurements and using a mathematical formula. The magnitude is stated as a number on what's known as the Richter scale. Scientists use an instrument known as a seismograph or seismometer to measure the seismic waves produced by an earthquake. The seismograph picks up the vibrations from the seismic waves and maps them on a piece of moving paper. The record of the seismic waves is called a seismogram. We've come a long way in understanding earthquakes, what causes them, and where they are most likely to occur. Of course, there's always more to learn, so as long as there are earthquakes, there will be scientists studying them.